All right, folks, so this is the last video for R2, for 1.1 actually. And what we're going to do is we're just going to summarize the transformations that we've done so far and the effects on the graph that we have seen. So if we look at the first case here, we've got y equals f of x, and then after we have a plus k. This created a vertical shift, so a movement up or down, or we could say the y values were affected. If we're looking at this mapping notation, so we've got our original x and y point, and the path on which the path that was that created the transformation, the effect on the y was when we added a k value to just the y values. And I just want to state, when k is positive, we move up or shift up, and when k was negative, we move downwards. And if we look at the other one here, we have y equals f of x minus h. Now this x minus h, that's all in the bracket. So the effect that we saw here was on the x values, and it gave us a horizontal shift. So we moved left or right. Now our mapping was, if we started with x and y, the path that took us to our shift was adding a value to our x, and that's it. Oh, this should actually be a y right here. Okay, because there was no change in the y. Now, if you want a little trick to help you remember which direction to move, if you're looking at it in this form, it's going to be opposite to the connecting sign. And I'll talk about that a little more after we've summarized this. So we could either look at it in this form where you've got f of x minus h plus k, or sometimes you'll see the k has been moved over to the other side of the equal sign, and they've just subtracted the k on both sides and ended up with this on the y values. Okay. Personally, I think it's just a little easier to look at it like this, then you could see whether the y value, whether it's shifted up or down, and you don't have to worry about the negative sign. All right. So when we're comparing two graphs, we're going to look at this example next. This example here, it shows us g of x. So g of x is after the transformation. So after transformation. And f of x, this we want to know what was our original graph. Okay, so that's the question that's being asked. So if we started with f of x, how would we have gotten to our g of x? So what we have to do is basically we have to go backwards. So we have to undo all of the transformations that happened. So if we're looking at this, this would have been a right 1 and up 2 transformations. But now we have to go backwards. So the backwards of that is left 1 and down 2. And that's going to take us back to our original f of x. So let's take all the points here and let's do exactly that to it. So this point, we're going to go left 1 and down 2, ends up here. This left 1 down 2 ends up here. So that's that straight line part right there. And let's take this point, go left 1 and down 2. Take this, go left 1 and down 2. This one here, go left 1 and down 2. And then finally we'll take this point, go left 1 and down 2. So grab a straight edge and we could graph this, get us a nice straight line, and it doesn't continue, it just ends there. And this looks kind of ugly, so let's clean it up and make it look pretty. Okay. Maybe I made it thicker because of the axis there. You just want to make sure that you can see that there. So there's an end point, and it's ending there, okay? It's not continuous. So key point here is to undo the operations to get to the original. To the original f of x from the transformed g of x. Okay? So we have to go in the opposite order. All right. Now, there's a bunch of examples on the next page, so let's have a look at them now. Okay. Sorry. Okay. So this question is asking you to determine the equation of the translated function in the form y equals f of x minus h plus k. So just put all the transformations together that we have done so far. All right, so now if we look at f of x is going to be the original, and then g of x is going to be the transformed one. So let's look at this f of x here. And if you notice real quick, you might have already noticed that the original here is a parabola. This was the x squared parabola, and there has been done some changes here. So how has it moved? Well, let's just kind of look and notice that this vertex would have to go left 4 units. So left 4 units, and then it would have to go down 5 units. So then down 5 units. All right, so now we could write it, let's write it in this form here. Let's say, for instance, we didn't know that it was x squared, so then we just say that, okay, so g of x has had some transformations applied to f of x, and this is what it looks like. So we've got f of x, it used to be f of x, now it is left 4. Now, left 4, so we have minus minus, so then that's going to be a plus there. And then down 5 means minus 5. Now, let's say, for instance, well, we do know. So let's look at it and write it down as if we know that it is x squared. So let's use y equals x squared and then do our transformations on that. In order to do it this way, we need to be careful and make sure that we put things in the proper spot. So this is where our minus 4 transformation is going to go, or our left 4. So we open up our bracket, and now instead of x, we have x plus 4. That tells us that it's going left 4, and we need to square what that was, because remember it used to be x squared. So we have to change what's in here, keep the squared on the outside here, and then we're going to tack on that minus 5 because everything shifts down 5. Now I want you to take a second and I want you to notice the difference between this here and this here. This is the function notation, okay? And this is using the actual equation. Okay, so it's a little different. There's a difference here. There's a squared here, and here there's no square because it's assuming that it's just some generic random equation. And then we have this f of x plus 4 there. Okay. All right, now let's try the next one. You know what? You guys can do this, I think. Hit pause, try it. We'll see how it goes. Quick on the pause button. Okay, so now you're back and you're looking at, this is the original, this is the changed one. So just take a couple of the points and count down. This went down 9 units and this went right 4 units. So this is just a bunch of line segments connected together. There's no actual equation for it, so let's just use this notation. So g of x is going to be down 9, so that means I'm going to have my f of, I'm going to put that there because that's easier to do, and then 4 to the right. Now it's going to be opposite to the connecting sign, so that's going to be minus 4. So that's what that looks like. All right, and next question here. This is your turn. So hit pause, and then I'm going to just show you what the answers are for that one, okay? This is the original. You go up 6, right 4, so up 6, right 4. So this g of x, the way to do that is f of x minus negative 4 plus 6. Now notice here I have the minus minus. That's where I get my plus 4 from, and that's g of x. So this is the answer we're looking for. All right, now here we've got a and a prime. So this a is the original. We're going to think of that as our f of x. And this a prime, see it's got that little tick mark there, that's going to be our g of x. So that's going to be our transformed one. So to get a prime, that's going to be the same as g of x. What we do is we move each point left 8 and up 3. All right, so that's, if we are using it on our f of x, we've got x minus negative 8 plus 3. So we could just say our g of x here is f of x plus 8 plus 3. This would be the answer that we're looking for. Okay, so there's some homework questions there, and there's also this page that follows. I want you to try this yourself, so pause the video and try it yourself, please. I will show you the answers, so hit pause, okay? I'm just going to show you the answers. I'm not going to talk through it all. All right, so hopefully you actually hit pause and you tried the questions. So here we go. So we're just going to look at it in terms of this general form. And if we notice here, right 1, we have h equals 1. Left is h is negative 3. Up is k is positive 2. And k is minus 4. And then we end up getting this for our quadratic, for our absolute value, and for our reciprocal, and then for our any function. So that's general. All right, hopefully these videos have helped you so far, and I look forward to speaking at you in the next one.